Hey everyone, this is Matt with Learn Everything About Design, and in today's video we are going to start to finish a project, and that's something that I don't do very often. I like to start a lot of projects, and a lot of them are pretty much ongoing. And so today what we're going to do is we're going to get started on my KTM 450 SXF. There's hopefully just one thing left to do before I can really enjoy this bike. This video is going to be all about scanning, and we're going to be using the Revopoint MetroY Pro. And in the next video, we'll talk more about design and actually get a part machined for this. And so this video will talk about what needs to happen. In the next video, when we do the design, I'll talk more about the bike because there's a history to this bike and get into sort of those facets of it. Remember, we are a Revopoint affiliate. If you're looking to buy, I'll leave our affiliate link in the description of this video, as well as our discount code. Right now, today is March 12th, and I don't know how long the sale is going on for, but there is a spring sale on Revopoint. There is an additional 2% off code that I'll leave in the description of the video. And so if you're looking to buy, pretty much everything's on sale now. It's a good time to buy. The last Revopoint video we talked about a scanner comparison. We looked at the full lineup from the Mini 2 all the way up to the MetroY Pro, which is kind of the top of the line laser scanner that they have, excluding the Trackit. And in that video, we talked about the Range 2, which I don't believe is available directly from Revopoint anymore. So if you have a Range 2 or you find one used, hopefully that video will help you there. If you're looking for a replacement for that, the Morocco is the next one that I would say is really a good replacement for what the Range 2 could do. All that out of the way, let's go ahead and talk about what we're doing today. So this is my 2011 KTM 450 SXF. I have a street title for it. I have done a wiring harness for it. I've got a speedometer, brake light, everything else is ready to go to get this thing inspected and on the road. The last thing that's holding me up is actually the kickstand. Now, the problem with the kickstand is really that because it's a motocross bike, there was only one company that made a kickstand for this bike. This specific bike was an ex-AMA race bike. The rear shock has actually been shortened a little bit, which makes it a little bit lower to the ground. Right now I have dual sport tires on these rims. I also have a set of supermoto rims and a set of dirt rims. The dirt rims, the kickstand is fine, but for the dual sport rims, and especially for the supermoto rims, the kickstand is way too short. And what I mean by that is right now, if I were to turn the bars to the right, the bike would fall over. And so I need to shorten the kickstand up and make it work better so that it works at least in the dual sport trim. My supermoto rims are, right now they're track only because the front is a 16.5, so there's no DOT tire for it. That doesn't mean that I might not get a set of street supermoto rims for it. And in that case, I want to have the flexibility of having a kickstand that works. I've had bikes in the past where I've converted them to supermoto and the kickstands were too short and it was a giant pain. And so this thing could only really be parked on a hill or if there's just a little bit of a breeze or if I happen to leave the handlebars turned to the right, it'll just fall over. And so that's not a great solution. That's something I need to take care of and make sure that it is something I can ride and I can enjoy. And so what we're gonna do is we're gonna take a look at scanning the kickstand that I have, because again, it's the only one that's available. There are some little problems with it. And then I'm going to work up a design that is either a replacement for just that part of the kickstand or potentially cut it and have an adjustable section on the end of it that I can use. Now, I'm a little hesitant on that because it'll make it thicker. So I need to work out how that can possibly be done. It does hit the bodywork, it hits the number plate when it's in the up position, so there is that problem. If I had a TIG welder here that could do aluminum, I would just simply cut it, shorten it, and weld it back together. I don't, and so what we're gonna do is we're gonna see if we can come up with a sort of a more flexible replacement for it. So the first thing is for me to get an idea of how short I need it to be. I've already measured it and I think I've got a good idea. That's something I definitely need to check, but the next step is to remove it so we can scan it. So let's go ahead and get started by taking this thing off. All right, so now that we got the kickstand off, there is essentially there's a mechanism inside here. There's a pretty heavy duty spring. There's a stamped steel plate. that retains this. I believe the pivot point is actually pressed in, it's not screwed in. And there's basically a cam system on the inside. Oh, it's really, really stiff. And with that, there are two little linkage arms that screw into the outside of this, and there's a rubber bumper on the side. So looking at the size and complexity of this, I think the easiest thing to do is likely going to be to bend this a little bit more, because I'm assuming they, just looking at the material, they machined this straight, they bent it a little bit too much. I think this needs to be a little flatter here. And cut off the end, drill through this end piece here, and then create a secondary piece that allows me to move it up and down to two separate positions. And so again, that's going to take a little bit of guesswork. Likely what I'll do is do some planning, cut this, make some 3D printed parts to test it out. Obviously it won't hold the bike up, but that way we keep this foot, but hopefully get it a bit farther away from the bodywork. The 3D printing parts will let us do some testing on that end. But for this video, what we really need to do is scan it. And I don't really need the mechanism stuff up here. What I really need to focus on is down here on both sides. And so the way we're going to do that is we're going to use the Revopoint marker block kit, which is going to be physical markers. That way I don't have to put any dots all over this thing, and hopefully it'll give me a good enough result. So I'm just going to go ahead and set that up. My overhead lights and laptop are taking up this outlet, and so I would need to get a extension cord over here, which I don't have at the moment. So we're just going to go ahead and do it wirelessly. There we go. So we got that. I'm going to put this on the marker mat that I have, and then pull out some marker blocks. So this is the 2nd gen marker block kit. I believe the biggest difference, these are like a rubberized texture, where the other ones were hard plastic, and they have more of a matte finish. The first ones were a little shiny. And so just setting these up around, and even using some of the triangles or the pyramids. There is a second layer to this kit as well, with larger domes. Again, all these are this sort of like rubberized flat texture. So I'm just gonna place these around. And the main reason that we wanna do this is because it gives us markers when we're looking at the object from the side. Typically what ends up happening when you start to tilt the scanner down, you lose tracking because it can't go more than about 15 or 20 degrees off perpendicular without running into some issues. So if you just place objects like this around, it can help you get that sorted. And we're going to try to connect with Wi-Fi. All right, it's connecting. Let's point it down so it doesn't blind me. All right, so we'll start a new project. This is going to be KTM Kickstand. So this part is machined aluminum. I believe that it is clear anodized because the welds themselves don't look like just a raw weld would look. So I believe it's been probably tumbled and then clear anodized. You can still see end mill marks inside of here, so it certainly wasn't sandblasted or anything, unless this was done after the fact. The outside of it actually just looks like raw stock, with the exception of the chamfer on the side. So probably just bar stock that they bought. They machined this to make it look like it just wasn't raw bar stock. All right, so first thing that we want to do is we want to do a global marker. And we'll start a new scan. So the global marker is going to capture, essentially it's going to capture all of these marker dots for us without worrying about the object. And that will give us the reference that we need. I'm going to use the auto exposure. I generally I'm not a fan of auto exposure, but I've become more of a fan lately. And so what I want to do is I just want to make sure I capture all the marker dots on all the objects. That way we've got this sort of marker file, which means that we don't need to worry about dropping tracking. And when I scan, I'm probably not going to hold the handle. It actually rotates a little bit. We'll complete it. And so now we've got just a file with all the marker dots. The global marker can happen on pretty much any of the Revopoint scanners. We can determine what our target distance is. Now this, I don't really need a lot of fine detail. I've got some sharp corners, but when I go and bring this mesh in, I know that these are just extruded slots. So I really don't need a really high or dense mesh. So I'm going to set this to 0.5 for my target. Cross lines, general object, and then we'll start our cloud scan. And so cloud scan essentially is just using the global marker file. And again, I'm going to go ahead and just set this to auto for now. It does a decent job. In sort of the original days of, or the earlier RevoScan software, I did not really like the auto exposure, but it's gotten a whole lot better. And so you can see the object is on the screen is already turned blue, which means that we have enough points for that 0.5 millimeter. And because we want to get the side of it, this is why we've got those 3D markers, because that allows us to rotate down, get the side. I don't really need the stuff over here, but as long as I've got some markers in the view, it'll allow me to capture it. But I really want to get the detail of the area where I'm actually going to be creating a new part. So inside of those slots, go back this way. Now you can see, at least on the preview on the screen, if I hit the menu button, and now I'll cancel that. What I was going to say is if we try to zoom in on it, we can see that it's not getting all the way down into the deepest pocket. That's okay, because again, we have the information we need just based on the fact that it's a slot. But if we want to go back in, we can use parallel line or single line mode to capture more of that. All right, so what I'm going to do now is I'm going to, wrong button, I'm going to pause it. I'm going to zoom in and review it. Yeah, so you can see right there, it doesn't have the data on those inside walls. And basically what this means is I'm not getting it at a steep enough angle to capture that. So because of the global marker file, I don't really need to worry about tracking. But what I want to do is try to tilt it down as much as possible to see if I can get inside those areas. And again, we can use parallel or single line mode to get it to be a bit better. But generally with 3D scanners, and this is not unique to this scanner or any Revopoint scanner, but with scanners in general, you always want to be perpendicular to the surface that you're scanning, which makes it really tough to get down inside of deep grooves and areas like that. Now this bottom is at an angle. We're probably not going to get a very good scan on the bottom, but I'm still going to try. I'll go ahead and just move it around. There we go. So now I think if we zoom in, you can see we were able to get inside those areas. Now I'm missing a little bit there. Again, doesn't really matter, but what we have to consider is the depth cameras both need to see inside of that wall. So if I'm here, this depth camera can see, this one can't. So you really need to be pretty far down. So what we're going to try to do is just see if I can't get that. Now the view is a little crazy. Let's go ahead and rotate this view. All right, that's better. So I'm going to rotate this. Actually, let's rotate it this way. So that way both depth cameras are looking inside of those areas. Get as close to perpendicular as I can. Try to get some of those points. Now, one downside to the laser scanning mode here is there's no automatic base removal. You do have automatic base removal if you're using feature scanning on a full field mode, but for laser, you don't. All right, so I'm gonna flip this over. It's gonna be kind of at an angle here. Bottom is dirty, but whatever. Make sure we're still using global marker tracking, same 0.5mm setting, and we'll do a new scan. Again, it's on auto depth exposure. At any point in time, if the auto depth exposure isn't working, you can always hit the plus or minus to manually change the depth exposure, which is why I've started to prefer to turn it on at the start, because I can very easily override it during the scan if I need to. So we're just going to go back and forth, getting about a little over 60 frames a second. Again, I haven't noticed any performance difference with the wireless mode, which I think is pretty impressive. This angle is going to be a little bit difficult to get into the slot. This is a very thin slot on the back side of this part, so not really a whole lot that has to happen there. Again, with global marker, we can rotate the scanner around. We can move around as fast as we want. I'm not jumping all over like this just because it doesn't help me remember to get into all these little crevices. But with global marker, we can jump over to here and jump over to here and jump over to there without losing tracking. And that's one of the real benefits. So again, flip it over. Still want to maintain a good distance. And all right, as soon as we get out of view of the markers, that's when we start to have trouble, but looks okay. Go ahead and I'm gonna call that good on the back side. And then probably want to prop this thing up. I use some good old mountain bike tire sealant. Make sure, sometimes I've noticed that it switches to marker tracking for some reason. So just make sure that you keep an eye on that, because if you go to marker tracking instead of the global, or the what they're calling the global marker tracking, it will be slower. You'll get dropped frames and you'll just have to deal with the sort of slowness of it. With the global marker, again, you can kind of move around as fast as you want. It doesn't mean you're gonna capture everything, because you're still only bringing points back where the laser lines are, but it means that you can move around and focus on different areas as needed. You still need to kind of keep an eye on the distance away from the object. Go here. In the last video, I had a question when we did our comparison video, a question about when to use the provided glasses. And for me, the only time I use the provided glasses is when I am calibrating. For whatever reason, that seems to be the only time the lasers are really that bright. This plastic here is actually, it's shiny, but it's not that shiny. But the calibration boards are glass, which means that the lasers reflect off of them pretty severely. And so that's what I would say is that's the time I would use it. If you're scanning something reflective, that would also be a good time. All right, we're gonna try one more. Again, make sure it's on global marker tracking. Do a new scan, and I'm just gonna get the side here. It's always, at least in my mind, it's always good to get more scans than you think you need, because it's much easier to do it now than it is to come back and reset everything up. Now, I'm not gonna put the kickstand back on the bike until I'm done, but it does really help. Also notice I haven't re-recorded any global marker files. Even if some of the markers are occluded by the part, it still has enough reference information that I can just continue to do that and not scan a new one. If you happen to have marker dots on the part itself, I would suggest redoing the global marker file each time. Otherwise, you are going to have some missed references that you need on the part, And those are actually going to be pretty important. In this case, I don't have any markers on the part, so I'm not really too worried about it. Again, you want to be perpendicular to the part you're scanning. So let's move around here. I'll try to get this side. In general, what I try to do is get a really good scan of the top of a part, a good scan of the bottom of the part, and then at the very least a third scan that has some data for both of those. In Revopoint, if you're using the auto, basically the auto merge for multiple scans, what you can do is you can use that third scan to help align the first two, and then you can hide it and generate or merge and generate the new point cloud without it. And so even if it's not a great scan, it can be pretty helpful just to capture that third one. All right, so that looks like a pretty good reference. I think I've got enough on all three of them. Yeah, and so again, this one here, the main thing that I want to do is I want to use it to help align the scans if I need to. I might not need to. So I'm not too concerned with missing some information here, but now would be the time to capture it if you are worried about it. And so again, both depth cameras need to see it. It needs to be perpendicular as best as possible. So if you're trying to capture geometry, then you need to rotate it around so that both depth cameras are seeing what you're trying to capture and that they're as close to perpendicular as possible. The closer to perpendicular you are, the better result you're going to get in terms of the accuracy. If you're trying to scan something and you're 20 degrees off the surface, you might get something back, but it might kind of be junk. All right, just for good measure, while I have it here, I don't think I'm going to need it, but I'm going to go ahead and scan up top. Again, it's switched to marker tracking for some reason. Make sure that we use global. And also remember that the target point distance we have set to 0.5 millimeters. That doesn't mean we can't capture more and fuse at a higher rate. All that means is that's the point in which the color on the screen is going to change. It'll change to this blue color when we have enough data to capture that. So again, both depth cameras need to see everything. Just kind of work my way down. Because these slots are repeating features, that would cause some issues when you're trying to do an alignment, for example. But the slots are actually varying depths. The first slot closest to this mechanism is the shallowest, at least on this side, and then they get progressively deeper as it goes lower on the part. So for whatever reason, that's the case, but it kind of helps us because that means the slot on the back side, or that deep slot, can be the one I use to create my new part that's going to hold the end of the kickstand. And so it may turn out that the new part I create doesn't reuse the bottom foot at all. It just kind of replaces it, and that's probably what I'll end up doing. And again, I don't really need this for what the part I'm doing. I don't need any of this data, but it doesn't hurt to capture it while we're here. And again, I do want to clarify, nothing against the construction or the manufacture of this part. I think it's a really nice part. It was well worth the money that I paid for it. Again, it was the only one that was available for my bike at all. Just the problem is the kickstand is too long, and that's a common complaint that I've seen, at least for the KTMs. I think they make them for other bikes and they're a little bit better, but at least for the KTMs, the kickstand is too long. All right, we'll just get the backside for good measure, and then we'll call the scanning portion of this video done. So once again, this back piece, this is stamped steel. It is a little bit of a dull finish. It's not as dull as the aluminum part, but it is not a shiny, polished piece by any means. The backside of the frame mounting portion of it is, you can see all the machining marks from how they actually manufactured it. But the scanner seems to be picking everything up just fine. And I'm not on the shiny setting, it's just on a general object setting. And so that's all pretty good. Got to get as low down as possible to get that backside there. And I'm a little too close to the part. Let's just try to, I want to see if I can get low enough to get a little bit of the front side. That'll help with alignment when I put all this stuff together. Probably not going to be possible, but all right. Let's see what that looks like. So even in the raw point cloud, we can see that I've got the serial or the part number there. It's missing a little bit down here because that's pretty low. So in order to get that, I would probably just set it on top of this marker block if it'll stay there. Again, the global marker file should still work fine, even though we got a couple of extra marker dots in here. If there is a problem, it can just use marker tracking. It'll just be a little bit slower. You'll have to be more careful. You can't jump around the part. All right, so we'll do a cloud scan. Make sure we're on auto. And capture this. All right. So I mentioned it in our review video, but the MetroY Pro, in my mind, I mean, it makes sense. It's at the, oop, well, that's not going to help. If your part shifts during and moves the marker blocks, then you're definitely in trouble. So I'm just going to complete it there. But the MetroY Pro is obviously the best of the laser scanners that Revopoint has to offer. And that's no surprise, it's at the top of the list, but the big difference between it and the MetroX Pro, again, is Wi-Fi. And so if you need the wireless scanning capabilities like we used here, then the MetroY Pro is the one you want. It has the full field mode, whereas the MetroY does not have full field mode. It has also less cross laser lines, and yeah, just in general, they're pretty close, but in general, the MetroY Pro is the best of the best. So I think at this point, we've got enough data for what I really need, which is just this bottom portion. So again, this first slot on the kickstand is the deepest, and they get progressively shallower as it goes up. While scanning this, what my thought is that I won't use any of the original end of it. I'll probably cut it right at the bottom of this slot, or yeah, probably somewhere in this slot. And I'll use both of these slots to essentially create a part that fits in there. The problem is the bend or the angle change happens just after this slot here. So that part wouldn't be able to slide up and down. And so I'll have to just give it some thought. I'm not sure how well I can bend this back straight. It doesn't need to be perfectly straight. If this foot was offset, then I wouldn't really have a problem. So I just had to do a little bit of planning. Again, that'll happen for the next video. This video is mainly about capturing the scan data. So now that we have the scan data, we can go ahead and take it into the computer and start processing it. And so let's go ahead and pack all this stuff up, and then we'll move inside. All right, so now that I'm at my desk, I just prefer to have a traditional keyboard and a mouse. Makes it a bit easier, and a second screen. Now we can take a look at what we captured. Now, when you first look at the scan data, what we're actually seeing, if we zoom way in, is going to be a representation of where the points are. Now, this is done for rendering purposes. So instead of having a point in space, you can see that we've got these little sort of boxes, or really planes. They're not 3D. And this is what is representing the geometry that we created. And so what we're going to do from here is the first step is to fuse the points together. Now, this is kind of, in my opinion, a little bit of a pain because there's no removal of the base. So we have to fuse the points across the entire scan. It's okay. Now, when we go to the fusion step, you'll notice that it gives us a recommendation here. Now, I typically will go to high quality instead of fast. You can go to the little info button here and it'll talk about it. And it depends, it kind of adjusts the fitting method of what we see on the screen here, the graphical preview, to the actual points that are getting generated. And I generally would say to use the recommended setting unless you have a good reason not to. You can certainly use a larger number. A smaller number generally will not work well. And so what we're going to do is we're going to apply that. It says estimated time 6 minutes. Usually doesn't take as long as it says. But one thing I've noticed during this process, you can see down here it's set to CPU acceleration. Now, if we cancel that and we go into our properties, into our preferences, you'll notice that here it says enable GPU accelerated rendering. And then up here for compute acceleration mode, it's set to CPU. You can change this to GPU, but it will depend a little bit on the specific graphics card you have. You can see here it says that mine, I have an RTX A4000. It said it may face compatibility issues, unable to generate point clouds, experience crashes. And so that's why mine is set to CPU acceleration. Depending on what you have for your specific computer, you may find that you can set it to GPU acceleration. Typically, this will happen when you first start Revo Metro, or the version of RevoScan that we use for the Inspire or any of the Metro series scanners. That's typically when it'll go through that performance check and it'll make those settings for you. And so when you're scanning and capturing, that can be different, or at least the display on the screen can be different. That can be GPU based, while as the processing may end up being CPU or GPU, depending on your card. Now, I have scanned with this desktop before, and I've used both CPU and GPU. I have had some trouble on GPU acceleration, not all the time, and so it's inconsistent, so I just leave it on CPU for mine. But let's go ahead, we'll let this process, and then we'll hop back in when it's done. Now that the fusion process is done, we can zoom in and see the preview of what's been done. So you can see there is a slightly different sort of layout of these graphical preview blocks. And now what we want to do is get rid of anything that is not that. And so typically the first step in this process is looking at what you might not need. And so the scan quality over here isn't great. It's not something I really want to keep. So what I'll probably do is hack off some of this. So just use the lasso tool and hack that off, hit delete. And then the quickest way for me is to go to this option here, which looks like a little donut with a bite out of it, and then click on the piece I want to keep. And so what this will do is it should select everything that is touching that. And then we're going to invert the selection and then hit delete. Now you can see a piece of it was still sort of kept here. So what I'm going to do is rotate this around and see if there's a reason. I think maybe it might be touching over here, or at least relatively close. Yeah, so that's the problem there. It's just in that corner. Go ahead and delete that. And then we'll try again. And now what should happen is only the kickstand will be selected. We can invert and hit delete. And then that's a sort of a quick way to handle that. You can see it did a pretty good job. You can see the welds. Now we're still looking at the points. It's not a true mesh yet, but we have enough information here. Now you might be thinking also, I could have just measured this, right? Like I didn't necessarily need to scan this. I could have just measured the width. It looked like it was standard bar stock, measured the slot and where I wanted to put the features. 100% could have done that. But sometimes it is nice to have these references, especially if we end up going above the angle, the part where it's bent. And so what I'm going to do from here is I'm going to move on to the next scan and just repeat the process. There's nothing different about processing a second scan. We just need to look at the settings that we want. We need to go through the fusion process so that way we convert them to something that is editable, because you can't remove any of these points until you go through the fusion process. You can see this second one, I didn't necessarily capture as many points, or some of the stuff on the outside may be influencing this number. I'm going to leave it at 0.27, even though it's below the recommended, just because I use that same number for the first one. And I know I mentioned that you really shouldn't do that, but again, I know that the points on the part I'm interested in, I scanned with enough resolution. It's really the stuff around the outside that's impacting that number. So if it messes up some of those extra sort of points around the outside of the part, I'm not too concerned with. I just need to take a look after it's fused and make sure that everywhere that I need data, I have data. Okay, so now we've got the second one fused and everything looks to be good. Again, what we're going to do is hack out the area we don't necessarily need. Remember, this is the back side. And so it may not have what we need to align on the front side. You can see we're missing a bunch of stuff. Historically, what we want to do, anywhere you've got a corner like this that's kind of messy, we want to clean that up. But for right now, I want to get rid of all the extra stuff. So once again, we'll use this option. We'll invert it, and then we'll delete everything else. And so with this one, let's go ahead and, you can see it lost the foot there. So what I'm going to do is undo. And let's go ahead and select this and this. And then we'll invert it and delete. And let's go ahead and see where it's hung up. Nothing should be touching, but the bottom here, this is actually just some dirt or contamination on the bottom of the part. Just go ahead and get rid of some of this. So they should be touching, but it looks like there's a little bit of a gap there. All right, so we'll select that. And it's still saying it's connected over there somehow. Where would that be? All right. The other way that we can do this is select that, and then we'll use our other tools here, and we'll just manually select it. So let's kind of work our way around. I don't see anywhere that it's connected, so I'm not sure why it's doing that. All right, so now that we've got that out of the way, again, what we want to do is anywhere that you've got a noisy edge, so basically if your scan stops here, you want to clear that out, because what's going to happen is when you put two scans together, it's going to, essentially it's going to influence the geometry in that area. We don't want that. So let's go ahead and zoom out. Doesn't have to be perfect, but we just want to get away from that edge. Now, if you use other tools like Revo Design or QuickSurface Lite, both are the same thing, there are ways in which you can clean up the boundaries of a mesh. But at the point cloud level, we basically just have to manually delete it. And so I'm going to cut that off, and then we'll rotate around to the other side. The mouse wheel is reversed from what I like, so I always get it backwards. All right, so I'm just going to get rid of basically everything here. Remember, this is why we do multiple scans, because we want to have enough data to where we can align multiples together. And we don't want to rely on just a top and a bottom. So we'll go down to here and call that good. I'm not too worried about the bottom. Again, we're hacking that off. I don't really need it. So now we've got two scans. We need at least a third to have enough data to align these. We could use the bottom. It is potentially possible to align it with the bottom, but it would be best if we've got some additional. So I don't know if I need that one. I'm not going to process it right now. What I want is the version of the scan that got the bottom and the top, so we're sitting on its side on the table. So let's go ahead and take a look at that one. All right, so here we've got a version of the scan with at least a reference on the bottom and the top that'll help us align. So we'll go to Fusion. Again, we'll just use that same setting. All right, so it looks like we've got this fused. Again, it's a bit messy over here. I'm going to go ahead and just get rid of that. Again, this is mainly for alignment purposes. Let's go ahead and see if it's touching anywhere. I don't think it is. So we'll see if we can capture it with this. Invert and delete. All right, so now we've got three scans, or three sets of point clouds. This one's mainly going to be used for aligning the other two together. So I'm not going to worry too much about cleaning up the bottom because, again, I don't need it. But we do want to go through the process of doing things like isolation and overlap detection. So for me, these are sort of key pieces of any step in the process. We want to go isolation to see if there are any points that are floating around, and then overlap detection. And we'll do that to the first one as well. Isolation. And a lot of times this can ensure that we don't have any sort of issues in corners or things like that. And then I'm going to go to merge. So we've only got 3 that we process. The rest of them haven't gone through the fusion process. We use feature alignment to see if it can put it together. Now, because the rectangle, the footpad is offset at the bottom, and it is captured in all 3 of them, I would hope it would do a good job, but it doesn't. So you can see there, for whatever reason, the yellow one is not working, but these two seem to be aligned properly. So what I'm going to do is generate the model between those 2, and then we'll try to align the third one to them. All right, so we'll take the merged one and this original, and we'll see if we can get it to do a better job with both of those in play. All right, so that looks a bit better. And we'll generate the model. Now, for the purposes of what we're doing, I'm not going to go through the process in this video to, let's go ahead and go to the top. I'm not going to go through the process of adding the additional scans where we did the top mechanism and the back and all that. And I can work on some of that stuff, but I don't really need to do it for what we're doing for this. And so if we zoom in, you can see kind of what we got here. So we're going to work with merge 2, and we're going to continue to turn this into a mesh. So now that we've got this, I don't really need anything up here because they're focused down here. So I can probably get rid of some of this as well. And let's go ahead and just delete that so we've got a nice clean edge. And then if we zoom in here, you can notice there's a little bit of messiness here. So after we merge multiple scans together, we want to go back through isolation. And if it detects anything, we can remove it. We want to go back through overlap detection. In some cases, overlap detection will find some of this. And if it doesn't, we also have a smoothing brush. Now you have to be very careful with this, especially on a corner. What I would say is zoom way in and try to smooth that area out. And then we will turn that back off and go back to the arrow here. And so on the bottom, you can see there's a little bit of data missing from that corner. We've got multiple scans where we could put that together. Again, I'm not super concerned with it for this, but we can go back to other scans that were captured. Let's see, maybe, which one should we do? Let's check the 4th one. And maybe it was the second one that or third one we skipped. Yeah, we skipped this one. So let's go ahead and just add this one, see if it's got a corner. Use the same data. And then we can try isolation detection before to remove some of the noise. And we want to make sure that it's not touching in this corner. It shouldn't be, but even if it's close, then the software will think it is. So we'll delete that. We'll try to select this, hopefully invert it. And let's go back. Let's add this piece. And then invert it, and then delete it. And then we'll run overlap detection. So this one's, the bottom piece isn't connected because I didn't do a very good job of scanning that. And we probably want to clean up that bottom edge. And again, so some of that is because I removed a lot from the scan data in those corners. I'm going to leave it on for this, and I'm going to go to merge, and I'm going to add, which one did we just do? 3? I can't even remember which one we just did. I think it was 3. Yeah, and then we'll see if we can't get those together. So the goal here is to try to fill in that corner that's missing. Let's just rotate it around. It's going to be a little bit messy, but I'll generate the model. And then we can go back to our modeling tools. So merge 3. Now we've got all the corners filled in. And again, it's a bit messy over here, so I'll just do a little bit of cleanup. The focus is down here, so I don't really need anything up there. But now that we've got this, once again, go back through isolation because we added another scan to the mix. We want to make sure that there are not any overlapping points. So you can see here, these overlapping points would cause us problems when we try to convert this. And then now we can turn it into a mesh. Now, the step to turn this into a mesh, this is where we need to be careful with these numbers. So the grid size, remember that when we scanned it, we set the distance between points at 0.5 millimeter. The grid size is going to, you can set the grid size lower than the value that you had for the points themselves. And what ends up happening is it'll create a triangle based on the larger point distances and then create triangles inside of those. And so it really only helps if you've got large flat areas. You're not going to magically get more detail or data that you don't already have captured. And so what we need to just be aware of here is the higher we set that number, which ultimately makes the grid size smaller, it's going to take longer to mesh, but it doesn't always mean that the quality of the mesh is going to be better. Generally, the lower number of triangles that we can get away with, the better the quality of the mesh will be. And so what I mean by that is, so for example, you can see the lines that were from the laser here. We can see some pretty good detail on the TIG welds on the bottom. But the lines that we had from the lasers, we can see those directions. And if we go to our display properties and we show the wireframe overlay, we can see how small these triangles are. And so to simplify this, it will what ends up happening is it's going to make the triangles larger. And what the result of that is that we get a smoother final mesh. And you can do this multiple times. You can always go back and remesh this. So if you're not happy with the results, as you continue to process, you can take a step back and start all over again. Let's go ahead and show this. But the lower number of mesh triangles we have, the smoother the end result will be. And the goal is really to get it down to the point where we have enough resolution to capture the details that we need, but not so much that we're making millions and millions of polygons. Now, right now, you can see here it says the polygon count's 150,000. And so if we can get that down smaller, so 10% or going 40% takes us down to 91. And if we keep going, you can see we're just continually refining it. And what we're doing is we're making these triangles bigger. And so once again, if we go back to our display and go back to solid, what you're going to see is that we're starting to smooth this out. The corner here is still looking pretty good. I mean, I think we've got enough. We're starting to lose detail on the welds. So you can see we're losing that sort of stacked dime look, but that's getting hacked off. I don't really need it. It's going to be used for alignment purposes, but I don't really need it. This right here is, again, a potential issue with actually the scan process. It's not necessarily a problem with the part itself. And the lower we make those triangles, we could get to a situation where these insides are starting to be pretty bad. Main thing that we need is somewhere in the middle. We need a good reference for getting a mesh section sketch. And so I think that is probably going to be a good result for what I need the part for. It could be better, but I don't really need it to be. And so I think that's the part where I'm going to go ahead and export this. So we're going to export the mesh model. And you notice that we have this option. So the coordinate is set at the center of the front surface of the scanned object's bounding box. So you can use the model origin or you can use the original origin, which was basically based off of the orientation of the first scan. And so I'm just going to, since I'm going to align it in QuickSurface, I'm not really worried about it. So I'm going to go ahead and I'll just toss it in here. I'm going to make sure it's an STL and we'll call this KTM Kickstand. Why did it change the name of that? Yeah, all right, let's go ahead and save it. All right, so now what I can do is I can bring this mesh into QuickSurface to do the alignment before moving it into Fusion. But again, the design portion of this is going to be in another video. The main portion of this was meant to talk about scanning and processing the scan here in RevoScan. And so if you have any questions on this, please let me know. I will continue to work on the rest of these scans and I'll I'll see if I can't get a full complete scan of the entire assembly, and then we can put that in the description of the video. But for right now, let's go ahead and just end this video because we're at the end of the RevoScan process, and just leave any comments or questions you have, and stay tuned for our next episode where we're going to be doing some design work and ultimately getting a part machined to replace the end of this kickstand. As always, thanks for watching, and we'll see you in the next one.